Hello, everyone, and welcome to a C++ tutorial. Today, I'm going to talk about classes and constructors. So we've seen a lot of different data types in C++ so far. We've seen integers, doubles, characters, booleans, strings, and each of them have important properties that we can use to make a wide variety of different functions and different capabilities within our programs. But as we get to more complicated programs, we have the ability to kind of increment our way there by creating our own data types that can be more complicated than integers or doubles. It can actually contain other types of data types. And the data types we create are called classes. And the way we do that is as follows. We're going to hop right into an example, and we'll be able to see all the reasons that it makes sense to do this and can be quite helpful. So we'll start off the way we initialize a class. We go class, use the class keyword, and then I'm going to make one called student. So we're going to have one for this object is meant to represent a student. Notice that, so we open a bracket, just like a function. We don't have parentheses here because it's not a function. But afterwards, we have a semicolon after the closing bracket. If you don't include that, you'll get a compile error. That's kind of just the way C++ is. So the things that we'll include in our class are two main things: member variables and member functions. And those will fall into two different categories, unrelated categories, called private, importance, and public. So I like to indent these a little more. Most people do. My IDE is a little funny with it. So things that fall into private can only be accessed by stuff that's within the student class. So if we have a member function that, say, changes the student's grade and the grade is under private, that's totally fine. But if we wanted to change the student's grade from somewhere outside of the class and the grade is stored under private, then we can't do that. We'd have to either make that a member function, make it call a member function, or actually store the grade in the public section of the class. So a lot of times, member variables are stored under private, member functions are stored in public. That's the way it's going to be until we start getting into more complicated systems that you can implement in classes. So things we would like to include: attributes about a student. So students generally have names. So string name. We're not going to initialize it right now. We'll get to that later. A character, that'll be their grade. And that's about it for this example. I'm told students are more complicated than that, but whatever. Just kidding. So public, this is where we put all of the functions that are meant to act on those classes. So if we wanted to change student's name or raise or lower their grade, you'd have a member function in there for that. We'll talk about that another time. That's not going to be the focus of this video. So when you write something like, if you wanted to initialize just any variable, you would write int number equals 0, and cool, and that is initialized. You created a variable called number, its value is 0, and it's an int, and so it's initialized. But we can't just write student yet, because we haven't explained how to initialize this kind of thing. And the way we do it is by using a constructor. And a constructor is formatted as follows. So you would write student, and then put some parentheses. If you don't include anything in there, we get what's called a default constructor. This would be if you literally just wrote student, something like student David, and left it at that. You'd be able to do that because there's a default constructor. And if we want to control what's in this, we do want to control what happens to the member variables. We want to initialize each of those within the constructor. So we would say name equals probably an empty string, and we would say grade. Everyone starts the semester with an A, right? So give them an A. Awesome. And that is our default constructor. But we can make more than one way to initialize this class. Let's say there's a bug in the system and some student doesn't get added until like later, like, they just missed somebody on the list, and you get to halfway through the semester and you're like, oh my God, we need to add this guy to our program. So we might want to make a student where you can take in like a person's name and take in their grade at the moment, and just go straight from there and like just add them straight to the system. And you want to manually input those, and you don't want to deal with like the member functions that we'll write later to actually change these. So you could write, so it takes in the string name in and grade in, and we choose like what variables in what order, and then we can just initialize those like so, the member variables, that is. So name equals name in, and grade equals grade in. Now we can initialize a student in a different way. So if we wanted to make another student, we'll call him Hayden, and we could just leave it at that and he'd be a default student. But let's say we're adding Hayden late. We can do a string. So his name is Hayden. That's the name we want it to have. And his grade is going to be, say, a C. Maybe he's not the most diligent student. And just like that, you'll create a different student with a different name, or and you can just input his name and input his grade. And you can make as many constructors as you want so that you can define students in whatever way that you choose. Like, for example, this would be a copy constructor. Sorry, put that in the wrong spot. So this would be a constructor that would just copy one student for another. So it takes the reference to a student in and just outputs an exact copy of them, which wouldn't be super useful in this case, but you could see other cases where this would be extremely useful. And so you can just make as many of these as you need to make your program work. All right. I hope this brief introduction to classes has been very informative. Thank you for watching, and good luck in your C++ endeavors.